In the previous episode, we started looking at how to eliminate some of the power supplies that we were using for our SR flip-flop. And if you remember, we had a 6-volt power supply for the heaters, a 12-volt power supply for our negative bias on the grid, and a 24-volt power supply for the voltage on the plate. And we were able to initially eliminate the 6-volt power supply by running the heaters of the two 6AU6 pentodes in series. And we used the 12-volt power supply for that, because each heater is equally balanced with its voltage and amperage requirements, which allows a uniform voltage drop across both of them. But then we built a Hartley oscillator to generate negative voltage and used that as our negative bias on the grids, eliminating the need for our 12-volt power supply, meaning that we could get it down to just a single 24-volt power supply. But when we did this, that eliminated our 12 volts that we could use to run the tube heaters in series. And furthermore, we had 3 tubes now, and that's kind of an odd number, and it's kind of difficult to figure out how to power the heaters of 3 tubes without having a separate 6-volt power supply. So I think I have a pretty good idea about how to tackle this. So let's hop over to the bench, take a look at the schematic, and I'll outline the idea, and then we'll build it on the breadboard and see how it works. So this is the schematic for our SR flip-flop with our Hartley oscillator over here on the left, and then these 2 capacitors and 2 diodes are generating the negative voltage out of the sine wave that's being generated by the Hartley oscillator here. And the problem comes from, well, our 3 heaters on the bottom here. Now we know that we can run heaters in series as long as they have equal voltage and amperage requirements. So these are all 6AU6 tubes, and they all have a 6-volt 300 milliamp requirement for the heaters. So if we want to run the heaters in series off of 24 volts, well, we actually just need 1 more tube, and we can run 4 heaters in series because 4 times 6 is 24. But where can we put another tube into this circuit? Well, there's actually 2 aspects about this circuit that I don't quite like, and it's not shown on the schematic here, but we're pulling our LEDs off of the outputs here, and we're using a little Zener diode to shift the voltage level that's coming out of this to something that won't blow up the diode, because we should be getting about 20 volts out of here at logic high, and then about 8 volts at logic low, and well, that's way too high for a diode. So I would like to get rid of those Zener diodes, and I would also like to get rid of these little diodes here. I think it would be cool to use a vacuum tube diode. And well, if we're going to use a vacuum tube diode, well, that's our 4th heater, and then we can just use some resistors and a voltage divider to eliminate the Zener diodes over here as well. And then if we do that, we can essentially eliminate all of the silicon out of this circuit, with the exception of the LEDs. And I initially wanted to use a halogen bulb or even a neon bulb, but neons require far more voltage than 24 volts, and halogens have a massive amperage requirement, which we can't really achieve with this circuit here. So I think what we're going to do is we're just going to replace these 2 diodes here with a dual diode vacuum tube. And it just so happens that the 6AL5 is a dual diode vacuum tube that has a 6-volt 300 milliamp heater requirement. So it'll work fantastically with these 3 heaters in series. So how are we going to hook that 6AL5 up in here? It gets a little confusing when we start drawing the schematic with these type of diode symbols. And so the best trick I've come across to equate a silicon diode to a vacuum tube diode is to think about it in terms of electron flow. So we have our silicon diode coming down like this. And the best way to think about it is that the electrons flow from this point outwards like this. That's of course not how it's shaped in real life, but it's a good way to to equate this to a vacuum tube diode. And so in a vacuum tube diode, remember that we have our plate, and then we have the cathode on the bottom. And of course, the electrons boil off the cathode and fly towards the plate, just like that. So our cathode is going to be this line here, and our plate is going to be the bottom of the triangle up here. So if we just redraw this little combination of capacitors here, so just like before, we have our 22 microfarad capacitor coming in here. It comes into both the cathode of one diode and the plate of the other diode. And then the cathode of this diode goes to ground. And then the plate of this diode is our output, but also the other capacitor hooks up to that plate, and then it goes to ground. And so this is a fairly simple thing to hook up. So I think that if we pop our vacuum tube into our breadboard, we can get this working pretty well. And then we'll just run the heaters for those 4 in series, and we should be down to just one single 24-volt power supply. Okay, so here's our breadboard, and I've put the SR flip-flop on this right half here, and then the Hartley oscillator is right here on the end. And I've actually gone ahead and put in the little jumpers here for another vacuum tube that is going to be the 6AL5 that we're going to put in here. As far as changes from the previous episode, I've changed the LEDs slightly to have a 33,000 ohm resistor into the LED, and then a 5.6 thousand ohm resistor as a voltage divider. So the output goes through a 33,000 ohm, and then the LED and the 5.6 thousand ohm are in parallel to ground. And this has shifted the voltage levels to something that the red and yellow LEDs here are much happier with. And it also eliminated the Zener diode, so I'm quite happy with that. And so we just need to figure out how to hook up our little 6AL5 vacuum tube here. And the first thing I want to do is I want to hook up our heaters in series. So the heater is going to be on pins 3 and 4 here. And so we need to come off of the heater from this one and into pin 3, and then out of pin 4 and into pin 3 of this one. So I've got some jumpers here, and I'll go ahead and pop those in. We'll just scoot those forward a little bit here. There we go, and then we'll take this jumper, just like that. So you can see we come off the positive voltage rail here, so that's going to be 24 volts into pin 3, out of pin 4 into pin 3 for this one. There will be a 6-volt drop across that, so it should be 18 volts coming into here. And then out of pin 4, all the way over into pin 3 of this one, and there will be a 6-volt drop across that, so it'll be 12 volts here. And then a 6-volt drop across this one, so 6 volts coming out of pin 4, and then finally into pin 3 on this one with pin 4 pulled to ground. All right, so that should be our heaters sorted. So let's flip this back around here. The next step is to figure out how to get all these pins going. And so if you remember, the output from the Hartley oscillator goes through a 22 microfarad capacitor. So I've got one of those right here. So I'll just go ahead and stick you in like there. And it goes through that 22 microfarad capacitor and goes into, well, the plate of one and the cathode of the other. And it just so happens that that works out to be pin 1 and pin 2. So we need to tie pin 1 and pin 2 together with a little bitty jumper. And I've got the smallest jumper in my collection here, so we'll use that. There we go. So that ties pin 1 and pin 2 together. So we've got pin 1 and pin 2 taken care of, and pin 3 and pin 4 are the heater. And then pin 5 is the cathode of the first diode, so it just needs to go to ground. So we're just going to run a little jumper to jump pin 5 to ground. Now pin 6 is a no connection. There's nothing going on pin 6, so we're just going to leave it floating. Pin 7 is the plate of our last diode. And so coming out of the plate of the last diode, we have our output as well as a capacitor. So our output, I'll go ahead and use a jumper to run it over to the resistors here that are acting for our grid bias. Okay. And then finally we have a capacitor, and the capacitor has the, well, because we're generating negative voltage, it has the positive end of the capacitor going to ground and then the negative end going into pin 7. So we'll just take you like that, and well, that should be it. Let's pop a 6AL5 tube in right quick. Okay, and well, that should work, and it should only require 24 volts. So I'm just going to use my little 24 volt wall wart here, and that's it. So I'm just gonna hook it up right here. We're gonna put the negative into the negative and the positive into the positive, and these jumper wires on the side connect these two rails to each other. And then, well, I'm just gonna go for broke here. We'll just plug it in and go. Now it takes it a little while to warm up because a couple things have to happen. First, all the tubes have to warm up and get warm enough to start operating. But before our SR flip-flop here can function, we have to have enough negative bias voltage. So this 6AU6 needs to warm up first, then it needs to start oscillating, then it needs to essentially charge the capacitors enough to generate enough bias voltage for our SR flip-flop to start operating. So it takes it a little bit of time to get there. All right, now because it's really, really bright in this room, it's actually really hard to see this yellow LED unless you're looking at it from straight on. And I like the red and yellow LEDs here because they feel a little more nostalgic and kind of fitting with the theme of this. But the yellow LED is on right now, so the red LED is off. So let's push the button and see what happens. Awesome, look at that. Okay, so it might be difficult to see again because it's so bright in this room, but the red LED came on, and as a matter of fact, if you're looking at it from straight above, it's quite bright. But the red LED came on and stayed on, and the yellow LED went off. And if I push this button, the LED came on, the yellow LED came on, and the red LED went off. So our 6AU6 SR flip-flop is working, it's functioning, it's flip-flopping back and forth with our little buttons here. And the heaters all run in series, so that's working out really well. We have no diodes in it except for our two LEDs right here. So this is awesome. This is the display piece that I was working towards. And you know, I'm really, really happy with this. But I don't think I'm gonna leave it just at this. I think I can make this look a little cooler by building a circuit board for it. So let's do that. Let's build a circuit board for this to build the final display piece. Just a quick note about how I'm designing this. I'm using a program called DesignSpark PCB. I really enjoy this program. I find it pretty easy to use and intuitive for novices like myself, but also it seems to be pretty powerful, and I haven't run into any limitations with it just yet. So you'll notice that the traces, which are the blue lines, are quite thick, and that's because I use about a 1mm trace width. And that's actually really thick for PCB, but I find that width tends to cut the best on our mill. I'm not using a specialized PCB tabletop router. I'm using a quite large, old school Bridgeport EasyTrack mill, and it was never really designed to do anything as small as PCBs, but it seems to hold up pretty well if I use larger traces like these 1mm traces here. Now that I've got a design that I'm pretty happy with, I'll pull it into a program called FlatCam. This is also a free program, and change the Gerber files that DesignSpark PCB outputs into G-code files, which is what our mill can actually read. And so FlatCam is a really good program that does that pretty intuitively. And if you want to know more about FlatCam as well as DesignSpark, please check the link in the description below to one of my previous videos where I go into a lot more detail about all of the different settings and how I have these set up and running on the mill. The first step that I do when milling a PC board is that I take a large bit and I mill this block of wood that's bolted into our vise flat. This way I know that the surface that I'm going to mount the PCB to is perfectly flat with respect to the spindle. And then I just use double-sided carpet tape to mount the PCB down. And I find that this actually seems to work pretty well. Cutting a PC board is a pretty low-stress operation for the mill, so the stickiness of the carpet tape seems to be strong enough to hold the PC board in place during the entire cutting process. All right, here comes the moment of truth. Let's plug it in. Flip the switch. Okay, it might be a little tough to see, but both of the LEDs are on, and that means that we've got power and the tubes are starting to warm up. So we'll give them a chance to warm up. Remember, this back tube has to warm up, and then the Hartley oscillator has to start oscillating to create negative voltage through our little capacitors here before the flip-flop will actually start doing its flip-flop business. All right, it might be a little tough to see, but it looks like this yellow LED is on and the red LED is off. So why don't we push a button and see what happens? Yes, look at that. The red LED came on, the yellow LED went off. If I push this button, the yellow LED goes on, the red LED goes off. So there we have it. We have a working SR flip-flop display that runs off of just a single 24-volt wall wart. That is epic. Oh, I'm so happy with the way that turned out. I am just beyond stoked. The LEDs could use to be a little brighter in this room, but on my desk, they're actually a pretty good brightness. In this room, I've got a ton of lights on, and there's a lot of natural light coming in as well, and that kind of washes the LEDs out. You know, at night, I think this is probably going to be even cooler looking, because not only will we get the LEDs illuminating at probably the perfect brightness, but we'll also get the glow of the vacuum tubes. this is super cool. I'm super happy with the way that this turned out. I think it looks awesome. It's really small and compact. It runs off of a single power source. I'm just, man, I could not be happier with the way that this ended up. This is epic. Man, I know it seems a little weird to be super excited about being able to turn a yellow LED off and a red LED on, but boy, that's just the coolest thing ever to me. So I'm gonna set this up on my desk, and I think it'll be a cool little distraction whenever I need to pull my eyes away from the monitor or away from work. And man, I'm just super happy. So in the next episode, we'll continue with some other interesting things. But for now, boy, I'm stoked with the way this turned out. I'm super happy.